The story of our world is written in stone, a silent library of epochs spanning 4.5 billion years. Each layer of rock is a page, each fossil a character in an impossibly long and complex narrative of primordial fire, creeping ice, and the relentless tenacity of life. Against this immense backdrop, the entirety of recorded human history, our empires, our art, our gods, is less than a single hastily scribbled word at the very end of the final chapter. We have barely learned to read this geological library, yet we carry ourselves as its authors, convinced that we are the inevitable climax of the story. Full of this conviction, we lift our eyes to the cosmos, scanning the silent, star-dusted darkness for a signal, a sign that we are not alone. We listen for whispers from distant worlds, hoping to find another mind in the great, empty expanse. But what if, for millennia, we have been looking in the wrong direction? What if the most profound discovery awaiting us is not in the sky above, but buried miles beneath our own feet? We must dare to ask a question so radical it borders on scientific heresy, a thought that threatens to unravel everything we believe about ourselves and our place in the timeline of life. That question is not, are we alone in the universe? But rather, are we even the first intelligence to arise on Earth? This suggestion is a tectonic shift in perspective, positing that we are not a singular miracle, but merely the latest iteration in a cyclical story of consciousness. It is the haunting hypothesis that an advanced industrial civilization rose, flourished, and vanished long before the first dinosaurs walked the earth. The immediate logical objection is simple. Where are the ruins? If a civilization existed hundreds of millions of years ago, where are their megalithic cities, their superintelligent machines, their planet-spanning monuments? The answer is as simple as it is humbling. Time, the ultimate destroyer, has erased them. The surface of our planet is not a static museum. It is a dynamic, violent engine of renewal, constantly grinding, melting, and remaking itself through erosion, subduction, and volcanic upheaval. Over the span of just a few million years, a blink in geological time, every trace of our own sprawling civilization, from our steel skyscrapers to our last plastic bottle, would be weathered into nothing more than a fine, indistinguishable layer of sediment. The great, indifferent sculptor of deep time leaves no statues standing. So, how would you search for a ghost? This is precisely the question that prompted a fascinating and rigorous thought experiment from two leading scientists, NASA astrobiologist Gavin Schmidt and University of Rochester astrophysicist Adam Frank. Initially, they were trying to imagine what biosignatures alien civilizations might leave behind on other worlds, before turning that same lens back onto our own planet's deep past. They called their hypothesis the Silurian hypothesis, a playful nod to a classic Doctor Who storyline featuring an ancient, intelligent reptilian species that predated humanity. But their work is far from fiction. It is a serious forensic framework for detecting the undetectable, a guide for finding a needle of intelligent activity in a geological haystack the size of a planet. Their proposal forces us to look not for artifacts, but for a shadow, an indelible chemical scar burned into the rock record. An industrial civilization, by its very nature, wages war on its planet's equilibrium, consuming energy on a scale that fundamentally rewrites geological processes. Its engine runs on stored sunlight, burning through fossil fuels like coal, oil, and gas that took nature hundreds of millions of years to patiently create. This act of global combustion is like hitting fast forward on the geological clock, flooding the atmosphere with carbon dioxide at a rate that nature cannot match. That carbon doesn't vanish. It is absorbed by the oceans and eventually buried in sediment, leaving behind a permanent and deeply unnatural isotopic signature for anyone who knows how to read the stone. And that carbon fingerprint would only be the beginning of the evidence. An advanced species would inevitably redesign its world, leaving multiple, overlapping clues of its existence. Imagine their agriculture, which might have released vast quantities of nitrogen from fertilizers, permanently altering the planet's nitrogen cycle. Consider their manufacturing, which would concentrate rare metals and create novel synthetic compounds, microscopic plastics, industrial pollutants, forever chemicals, that could become fossilized into a new type of rock. Even their ultimate demise, whether through nuclear conflict or reactor meltdowns, could leave behind telltale pockets of radioactive isotopes like plutonium-244, which do not occur naturally and serve as a long-lived tombstone marking a nuclear-capable species. This is where the thought experiment transcends a fascinating intellectual puzzle and becomes a chilling self-portrait. The very signals the Silurian hypothesis proposes we search for in the deep past are the exact same signals our own global civilization is broadcasting, with alarming intensity, into the geological future. We are currently creating our own carbon isotope anomaly with every factory smokestack, every car engine, every transatlantic flight. We are seeding the oceans with a blizzard of microplastics that will one day become the defining fossil of our age, a permanent testament to our throwaway culture. We have unleashed radioactive isotopes that will long outlive our species, a permanent signature of our brief, brilliant, and violent dominion over this planet. In searching for their shadow, we are staring directly at our own. The Silurian hypothesis, therefore, is more than just a search for a lost civilization. It is a mirror held up to our own precarious moment in history. It challenges the comforting myth of human exceptionalism, suggesting that we may be just one turn of a great wheel that has spun before and could spin again. Are there strange, unexplained events in Earth's deep history? Sudden warming periods, mysterious extinctions, odd chemical spikes that fit this profile? Are there whispers in the rock record, faint chemical echoes of predecessors who rose, built, and ultimately fell? Join us as we journey into deep time, on an archaeological dig for a ghost. In searching for their story, we might just uncover the unwritten ending of our own. To hunt for a civilization buried by 300 million years of geology is to become a detective on an impossible scale. The crime scene is the entire planet, and the suspect is a ghost. We cannot look for buildings or bones. They have long since turned to dust and then to stone under the immense pressure of ages. Instead, we must search for the indelible traces that large-scale activity leaves behind, the planetary-scale scars that even deep time cannot fully heal. This is the domain of forensic geology, a search not for objects, but for the profound disruption of natural processes. We must learn to recognize the very signature of industry itself, a fingerprint composed not of lines, but of atoms scattered within a layer of rock, a signal hidden in the noise of a billion-year-old story. The most profound signature would be written in the element of life itself, carbon. All life on Earth has a chemical preference, favoring a lighter isotope, carbon-12, for its biological processes. Over millions of years, countless forests and plankton blooms died and were buried, sequestering this preferred carbon-12 into vast subterranean deposits of coal, oil, and gas. An industrial civilization, upon discovering this treasure trove of condensed sunlight, would burn it for energy at a furious, unnatural pace. This act of global combustion would release a colossal plume of that lighter carbon back into the atmosphere, fundamentally altering the global carbon ratio in a geologically instantaneous way. This change is the price of industrialization, and its evidence would be locked away in limestone for eternity. Beyond carbon, any technological species would become an unnatural geological force, a global alchemist rearranging the periodic table. They would mine the Earth's crust, extracting rare elements and concentrating them in ways nature never could, then dispersing them across the planet's surface. Imagine the global signature of lead, mobilized for electronics and fuels, or the sudden appearance of cadmium and mercury as byproducts of their industrial ecosystems. These heavy metals, once safely locked away in mineral veins, would be released to settle into a thin, poisoned layer in the sedimentary record. Finding such a specific geochemical spike would be like finding a manufacturer's label stamped onto an ancient rock face, a clear sign of artificial processes. Perhaps the most unambiguous clue, a true technofossil, would be a material they designed to last forever. For us, that material is plastic. We have created billions of tons of these synthetic polymers, molecules so alien to nature that almost no organism can consume them. They do not biodegrade. They simply break down into smaller fragments, a cloud of microscopic dust that now permeates every corner of the globe. Over geological time, this synthetic dust would settle and be compressed by immense pressure. It could form a new, horrifying type of rock, a plastoglomerate, a fossilized testament to a civilization's addiction to convenience and an unmistakable sign of artificiality. There is one signature, however, that speaks not just of industry, but of a species that has unlocked the power of the atom. That signature is nuclear. While natural nuclear fission can occur, only advanced technology produces certain long-lived radioactive isotopes in significant, widespread concentrations. Elements like plutonium-244, a byproduct of nuclear reactors, or other unusual elements from atomic weapons, would serve as definitive proof. Though they decay over millions of years, they leave behind specific daughter isotopes in a predictable chain. Finding a concentrated layer of this radioactive ash would be a chilling discovery, the ghostly whisper of a species that wielded godlike power, and perhaps paid the ultimate price for it. Finally, a civilization's industrial footprint on the planet's chemistry would be mirrored by a biological catastrophe in the fossil record. The rapid acidification of the oceans, the global dispersal of toxic metals, the sudden warming of the climate. These are violent shocks to the global ecosystem that would inevitably trigger a mass extinction. The geological record is a graveyard of such events, but most have clear natural culprits: an asteroid impact or massive volcanism. But what if we found an extinction that had no such natural alibi? What if a great dying coincided perfectly with a carbon spike, a layer of industrial metals, and a fossilized hint of synthetic polymers? This would no longer be a collection of anomalies. It would be a cohesive narrative of cause and effect. So, our forensic toolkit is complete, and the abstract hypothesis has become a concrete search strategy. We are armed with a checklist of specific, measurable evidence. We seek a rapid spike in lighter carbon isotopes, a sedimentary layer rich with an unnatural cocktail of industrial metals, and the fossilized remnants of synthetic molecules. We are listening for the faint, radioactive ghost of specific isotopes, and looking for a corresponding mass extinction that cannot be explained by the usual suspects. The hunt for a forgotten world is no longer a flight of fancy. It is a scientific mission, and we are ready to examine the suspect. We must now turn to the great stone library of Earth and see if these fingerprints can be found. Our theoretical manhunt now becomes a physical one. With our forensic checklist in hand, we leave the laboratory and step out onto the crime scene. The planet Earth itself, laid bare in its geological strata. We are now searching for a match, a moment in deep time where the planet's natural rhythm was violently interrupted, a place where the fingerprints of industry might be hiding in plain sight. Our journey takes us to exposed rock faces in desolate badlands, to deep-sea cores drilled from the ocean floor, and to the microscopic fossils that tell tales of ancient climates. We are not just reading history, we are looking for a conspiracy written in stone. Our investigation quickly zeroes in on a prime suspect. It is a specific chapter in Earth's history, an event so dramatic and abrupt that geologists still struggle to fully comprehend its cause. It happened 56 million years ago, a time known as the Paleocene-Eocene thermal maximum, or PTM. Over a geological instant, perhaps less than 20,000 years, the entire planet was gripped by a fever. Global temperatures soared by 5 to 8 degrees Celsius, the poles melted, and the chemistry of the oceans was thrown into acidic chaos. It was a global convulsion, a sudden heat stroke from which life took over 100,000 years to recover. The smoking gun of the PTM is its carbon signature, a clue so pronounced it feels like a confession. In geological cores from this period all around the world, there is a massive and sudden negative spike in carbon isotopes. This tells us, unequivocally, that the atmosphere was flooded with a colossal amount of isotopically light carbon, the very kind locked away in fossil fuels. Scientists estimate that between 3,000 and 7,000 gigatons of carbon were unleashed into the ecosystem. The scale is staggering, but it is the speed that is most unsettling. It represents a planetary metabolism gone haywire, a carbon release that dwarfs any natural process we can definitively model. Of course, science does not leap to conclusions of lost civilizations. The prevailing explanation for this event points to natural, albeit catastrophic, culprits. Geologists have identified a leading suspect in the vast volcanic activity of the North Atlantic Igneous Province, a period when immense lava flows could have essentially cooked organic-rich sediments, releasing their carbon. Another prominent theory suggests a methane bomb, the sudden destabilization of frozen methane clathrates on the seafloor, which would have released huge quantities of this potent greenhouse gas. These theories are scientifically robust, painting a picture of a planet pushed to its limit by its own internal forces. But here, at the heart of the mystery, is where the Silurian hypothesis makes its bold entrance. It looks at the PETM's evidence, the unprecedented speed, the specific carbon signature, and offers a different narrative. What if the trigger was not a volcano or a methane burp, but an engine? What if this was not the planet's own fever, but the exhaust heat from a burgeoning global industry? The data for the PTM is a near-perfect match for the projected geological footprint of our own Anthropocene epoch, just on a grander scale. What if we are looking at the tombstone of a civilization that burned through its planetary inheritance, a species that ran its world on fossil fuels and paid the ultimate price in a runaway greenhouse effect? If the carbon spike was the act, the subsequent extinction was the consequence. The PTM coincides with one of the largest extinctions of deep-sea life in Earth's history, as the oceans became acidic and starved of oxygen. This aligns perfectly with the biological catastrophe we would expect from such an industrial collapse. Scientists examining PETM sediments have also found strange anomalies, including mysterious layers of magnetized nanoparticles and spikes in metals like mercury, though their origin remains fiercely debated. While inconclusive, these oddities add another layer of intrigue, whispers of an industrial process that could accompany the main carbon event. This leaves us at a profound and humbling crossroads. The geological evidence for the PTM is undeniable, but its interpretation is not. The fingerprints of a massive natural catastrophe and the fingerprints of a civilization-scale industrial event could be, after 56 million years, virtually indistinguishable. The rock record may simply not have the vocabulary to tell us the difference between a planet's rage and the self-destruction of its own inhabitants. This ambiguity is the central power of the Silurian hypothesis. It reveals that the evidence for our own industrial age, when viewed millions of years from now, will look just like another one of these natural hyperthermal events. So, we stand at the edge of this 56-million-year-old crime scene with a tantalizing unsolved case. We have a geological body in the form of the PTM, and we have a forensic profile of a lost industrial civilization that fits its wounds almost perfectly. There is no confession, no definitive proof, only a profound and unsettling correlation that refuses to be dismissed. The whispers in the stone have become a coherent voice, suggesting a story we have never dared to imagine. The question is no longer just a thought experiment. It now has a name, a time, and a place. The question now is, who were they? Having found a potential crime scene in the deep past, we must now dare to imagine the victim. The cold, hard data of isotope ratios and sedimentary layers can give us a cause of death, but it cannot give us a face. To understand the story written in the stone, we must take a leap of creative, scientific imagination. We must attempt to reconstruct a lost world, to give flesh and form to the ghosts hinted at by the geological record. We shall not call them human, for they would have been born of a world and an evolutionary path completely alien to our own. Let us call them the progenitors, the first children of earthly intelligence. Their story would not have begun on the familiar plains of the Serengeti, but in a world that would seem to us like a fever dream. Imagine the Earth 60 million years ago in the Paleocene. The air is thick, warm, and humid, a global hothouse teeming with life forms that seem drawn from a fantasy novel. Strange, mammalian creatures scurry through the undergrowth of jungle-like forests that choke the continents. The oceans, warmer than today, are home to new forms of leviathans, and the world is still recovering from the asteroid that wiped out the dinosaurs. It is in this strange, recovering world that a new kind of mind could have taken root. What would they have looked like? We can only speculate, but evolution provides us with tantalizing possibilities. Perhaps they were not primates, but creatures descended from an entirely different lineage, one equally capable of complex thought. Imagine a species evolved from cephalopods, the ancient and intelligent masters of the sea. Their soft bodies, capable of radical transformation, might have allowed them to manipulate the environment in ways we can barely conceive. Their skin, a living canvas of light and texture, could have formed a language of unparalleled complexity, a silent visual grammar of ideas. Their cities would not be rigid structures of stone, but perhaps living, cultivated reefs of bioluminescent coral, pulsing with information. Or perhaps intelligence arose on the land, but not from fur and bone. Consider the arthropods with their exoskeletons, modular bodies, and hive-like social structures. An intelligent insectoid species might have developed a collective consciousness, their society operating with the seamless efficiency of a superorganism. Their technology would not be forged, but grown, using advanced biological engineering to create tools, habitats, and even machines from hardened chitin and silk. Their rise would not have been marked by the discovery of fire, but perhaps by the deliberate cultivation of symbiotic fungi that could break down rock and digest minerals. Regardless of their form, their journey to dominance would have followed a familiar, tragic arc. They would have discovered the immense power locked away beneath the planet's surface in the form of fossilized carbon from ages past. This discovery would have triggered their own industrial revolution, a sudden, explosive expansion of energy and capability. Their world, once powered by sunlight and chemistry, would now run on the ghosts of ancient forests. Their population would boom, their cities would spread, and for a time, they would have felt like masters of their world, their power seemingly limitless as they bent the planet to their will. This is the civilization whose faint, dying echo we may have detected in the rock of the Paleocene-Eocene thermal maximum. Their global industry, whether cephalopodic or insectoid, would have consumed fossil fuels with the same rapacious hunger as our own. The carbon fingerprint we see in the stone is the exhaust plume of their success, the feverish heat of the PTM, the planetary cost of their ambition. Their end may not have been sudden, but a slow, agonizing slide into a climate catastrophe of their own making. They would have watched as their oceans turned acidic, dissolving their coral cities, and as the runaway greenhouse effect boiled their world. Or perhaps their end was swifter and far more violent. A species intelligent enough to harness the energy of fossil fuels is likely intelligent enough to unlock the power of the atom. It is a grim but logical possibility that their civilization did not just fade away but was extinguished in a flash of self-inflicted nuclear fire. The pressures of a dying planet, resource scarcity, and ideological conflict could have pushed them over the brink. In this scenario, their tombstone is not just a carbon spike, but a faint, scattered whisper of unnatural radioactive isotopes, a final, horrifying signature of a civilization that achieved godlike power only to turn it upon itself. And so, the story of the progenitors ends. Their art, their philosophy, their history, their names, all of it was scoured from the face of the planet, consumed by geological time. Nothing remains but a subtle chemical anomaly in a layer of rock, an anonymous scar marking the grave of a failed experiment in intelligence. Their entire existence, their rise and their fall, has been compressed into a single cautionary data point. They have become a ghost story told by geologists, a phantom whose only legacy is a warning, etched into the very foundation of the world, a warning that we have only just begun to decipher. The journey into the deep past, in search of a lost industrial world, has led us to this critical juncture. We have examined the geological evidence, we have constructed a plausible narrative, but now we must confront the most unsettling question of all. So what? If the Silurian hypothesis is true, or even just plausible, what does it mean for us, the current self-proclaimed masters of this planet? The existence of the progenitors would be more than a historical curiosity. It would be a philosophical bombshell, shattering the very foundations of how we view ourselves. The discovery would force us to confront the uncomfortable possibility that we are not a unique miracle, but simply the latest chapter in a story that has been written before. For decades, we have stared into the silence of space and asked the Fermi paradox. If the universe is teeming with planets, where is everybody? One of the most compelling and terrifying answers to this question is the concept of the Great Filter. This is the idea that somewhere along the immense developmental path from simple life to a starfaring supercivilization, there is a barrier, a filter that is almost impossible to pass. For our own comfort, we have always hoped that this filter is behind us. We hoped that the truly difficult step was the initial spark of life, or the leap to complex cells, or the emergence of intelligence itself, barriers we have already overcome. But the ghost of the progenitors tells a different, far more frightening story. If a technologically advanced species arose on our own planet and then vanished, it provides a chilling new data point. It strongly suggests that the great filter is not in our past, but in our future. The hard part is not becoming an intelligent, tool-using species that can build a global civilization. The hard part, the nearly impossible part, is surviving that very success. The progenitors would serve as Exhibit A that intelligence and industrialization are not the finish line, but are instead the entry gate to the final and perhaps fatal test. What, then, is this filter that lies ahead? The story of the progenitors, as potentially recorded in the Paleocene-Eocene thermal maximum, points to a clear culprit: self-induced environmental collapse. The filter may be a fundamental law of civilizational dynamics, that any species intelligent enough to exploit the energy of its planet will inevitably do so at a rate that overwhelms the biosphere's ability to self-regulate. It suggests that planetary-scale industry naturally leads to a planetary-scale fever from which there is no recovery. In this view, nuclear war is not the primary threat. The exhaust pipe is more dangerous than the bomb, and the true enemy is a species' own unsustainable ambition. This realization profoundly reframes our sense of cosmic loneliness. We have long felt a solitude born of spatial distance, the feeling of being a single point of light in an endless, empty void. The Silurian hypothesis introduces a new, temporal loneliness, the solitude of being separated from our nearest intelligent neighbors not by light years, but by an impassable gulf of 60 million years of time. We are not just alone in space. We may be profoundly alone in our own historical moment, living in the ruins of a world we never knew and standing on the grave of a forgotten intelligence. We are the inheritors of a haunted planet. This cyclical narrative deals a fatal blow to our most cherished cultural myth, the idea of linear progress. We see ourselves on an ever-ascending path, from the stone axe to the starship, a singular, triumphant march of reason and technology. But a prior failed cycle shatters this comforting illusion. It suggests that history is not a line, but a wheel, and that intelligence might be a recurring planetary condition, a brief, brilliant fever that burns hot before inevitably burning out. Are we really destined for the stars, or are we just the latest species to briefly achieve global dominance before being ground back into the geological record? Yet, within this bleak philosophical landscape, there lies a sliver of profound hope. A prophecy is only a prophecy if you are powerless to change it. A warning, however, is a gift. The progenitors, if they existed, likely had no idea that they were a data point, no concept of a great filter, and no geological ghost to warn them of their impending fate. They walked into the trap blindly. We, on the other hand, can see the potential shape of our own doom reflected in the deep past. The knowledge of their failure is our greatest advantage. Ultimately, the philosophical weight of the Silurian hypothesis is that it places the burden of breaking the cycle squarely upon our shoulders. It turns our gaze away from the distant stars and forces us to look at the ground beneath our feet, at the carbon we pump into the air, and at the future we are currently writing into stone. We stand at a precipice they may have stood upon 60 million years ago. We are staring at the same filter. Their story, whether real or imagined, has shown us the path of least resistance, the path that leads back to silence and sediment. The question it leaves us is the most important one we will ever face. Are we capable of choosing a different one? Our investigation is now complete. We began with a radical question aimed at the stars and found ourselves on an archaeological dig into the very foundations of our world. We searched for the ruins of a lost civilization, for the glint of an artifact or the outline of a fossilized machine buried in deep time. We must be clear, we did not find one. There is no definitive proof, no smoking gun, that a society of progenitors rose and fell before the age of mammals. But what we found in our search is arguably more profound and infinitely more relevant. We found a mirror. The true power of the Silurian hypothesis is that it has nothing to do with a 60-million-year-old mystery and everything to do with the crisis we face in this very moment. The forensic checklist we assembled to find a ghost civilization, the sudden spike in atmospheric carbon, the global dispersal of novel chemicals and plastics, The rapid acidification of the oceans, the corresponding mass extinction, is not a hypothetical profile. It is a perfect point-by-point description of our own global civilization's footprint. The hunt for their industrial shadow has led us directly to our own. That strange negative carbon isotope anomaly we witnessed in rock cores from the PTM, we can see its twin forming in real time in ice cores drilled from the Greenland ice sheet, charting our own atmospheric disruption with terrifying precision. The theoretical plastoglomerate we imagined as their synthetic fossil? It is already being found on beaches today, as our plastic waste fuses with rock, sand, and shells. The extinction event we sought in the fossil record. Biologists now warn we are the driving force behind the sixth mass extinction, with species vanishing at a rate not seen since the dinosaurs fell. We are, at this very moment, compressing our entire story into a single thin layer of rock. We are actively composing our geological epitaph for the far future to find. When our time is over, our brief, brilliant, and violent reign will be summed up by this Anthropocene layer. Perhaps future geologists, millions of years from now, will debate its meaning. They will puzzle over the strange spike in carbon and the odd metallic traces, and they will argue whether it was caused by a natural supervolcano or if, perhaps, it was the signature of a short-lived industrial intelligence. We are in the process of becoming our own geological mystery. But here lies the crucial difference, the one variable that can change the outcome of this repeating story. The progenitors, if they existed, were pioneers of planetary-scale self-destruction. They likely stumbled into their climate catastrophe blindly, without the benefit of advanced atmospheric models, satellite data, or the geological record of past events. They were navigating their global crisis without a map. We, however, are not. We have the data, we have the models, and in the story of the PTM we have a clear and chilling precedent. Their potential failure is our warning. And so, the Silurian hypothesis transforms from a fascinating thought experiment into an urgent moral imperative. It gives us the profound and terrifying gift of perspective. It allows us to see our own civilization not as the pinnacle of creation, but as a single, recurring data point in a vast planetary experiment. It forces us to ask if intelligence is a successful evolutionary strategy or if it is simply a brilliant but fatal trap. Knowing the shape of the trap is our only hope of disarming it. The ghosts of the past, whether real or imagined, have given us a glimpse of our own potential future. The story of our civilization, therefore, will not be written primarily in our books, our digital archives, or even our monuments. The final, definitive history of our species will be written in the language the planet understands, the language of chemistry, of isotopes, of sediment. It will be a story told by the carbon ratio in a future layer of limestone and the microscopic fossils of the species that survive us. This geological record is the ultimate and most unforgiving historian, and it does not record intentions, only consequences. We are the authors of that consequence, the architects of our own fossil record. 100 million years from now, when all our cities have turned to dust and our languages are forgotten, what will our layer in the rock reveal? Will it show just another catastrophic carbon spike, another anonymous scar of a cycle doomed to repeat? Or will it show something different? Will it, perhaps, show a peak in carbon followed by a slow, deliberate decline, the sign of a civilization that saw the reflection of its own demise, and for the first time in Earth's history, had the wisdom and the courage to choose a different path?